Next up is Dave Apgar, who's the BCP, that is to say Business Continuity Planning, HA Architect at Yahoo, and he's going to talk about DNS-based global load balancing. Dave, are you there?
Oh, I am here.
All right, let's roll.
All right, cool. Slides are working. I can click buttons. So what I'm here to talk about is DNS-based global load balancing. The big piece of this is when you're at the point where you are deploying your website in multiple different locations for whatever reasons, availability, performance, because you don't like your first data center and you want to move to a new one. There's the glue that the majority of people use, which is DNS-based global load balancing. It's, as some people term it, stupid DNS tricks to route your users around. Concept behind this, we've been using this at Yahoo for forever, and we actually built our own platform for it instead of using providers at this point in time. But the concept behind it is anytime you want to go to a website on the internet, you have to do a DNS lookup to get the IP address for it. That lookup goes through to your ISP's DNS resolver. The way we handle it is you ask our DNS servers what the IP for yahoodns.com is, and it tells you to go ask our GSLB system. This gives us the ability to switch between them. You know, we use our own, and our own is awesome, so of course we wouldn't need to switch, but if we wanted to, we could just twiddle it over to some other provider. That system, in turn, knows about all of the possible places to serve the Yahoo front page. In my little example here, we just have Hong Kong, San Francisco, and New York for our web servers, but it's, of course, deployed in a bunch more places. That figures out that the users behind that resolver are in Hong Kong or near somewhere in Asia, so it hands back the Hong Kong VIP. Client gets a server that's 40 milliseconds away from them instead of being sent all the way to New York or somewhere in Europe or somewhere horribly far away. For me, hanging out in San Francisco, when I do my little lookup, if there's a bunch of other users, the answer for that's already cached. And in this little picture, I'm going to get sent to New York instead of San Francisco because there is a horrible searing fire on our web servers there. The biggest piece for this, from a performance standpoint, is getting users to the closest possible place. The speed of light is a fixed constant, except for apparently neutrinos. They're apparently a tiny, tiny bit faster than light. So for your web page loads, no matter what you do, Hong Kong's still going to be 200 milliseconds away from San Francisco. The east coast of the U.S. is going to be 80 milliseconds away from the west coast, and there is always a base amount of overhead for any TCP connection just doing that basic handshake. So if you have to, when you load that first piece of HTML, there has to be a TCP connection there to start getting that content. And then when you load out images, some things will load in parallel, some things will load in serial, but it's a chunk of overhead. And if you're sending a user to a place that's half a second away for the latency because it's going through bad links, bad networks, it will hurt their page load performance overall. The closer you can get your clients to, the faster you can have a page load, the faster pages load. There's been a whole bunch of studies that have been at the different velocity conferences and out on the internet that show that you'll get better click-through rates, better user interaction if you can do things serving them out of somewhere that is fast. So this is the easy, free way to get a boost in page performance without actually having to go twiddle your code and make things run faster. How GSLBs actually determine what's closest. The way we do it, it's a combination of magical pixie dust, unicorn farts, very, very important. That's how we figure out where users actually are, and wizards loading up epic dragons. The way it's actually done, it depends. All of the different GSLB systems, they kind of use their own sets of metrics. Some of them are as services. Some of them are pieces of hardware that you can deploy in your data centers. Some things are just what someone decides to cobble together. How it's done depends. Some of the different things are using BGP routing tables to try to make a map of the internet. Some of them do pings, use web beacons, use GeoIP databases saying, hey, if this user's in Taiwan, then I will send them to Taiwan. If they're in the U.S., I'll send them to the U.S. It really is the magic secret sauce of GSLBs, and it's kind of the, one of the holy grails is, can I have a perfect map of where the internet is and where everything is actually close? In terms of actual accuracy, doing traffic routing based upon DNS is not guaranteed to be accurate at all. Generally, it is fairly heavily accurate, but it isn't a guarantee. Sometimes users aren't near their resolvers. I could be sitting out in San Francisco, and my ISP decided that they wanted to deploy all of their DNS resolvers over in New Jersey just because, hey, that's a central place. They got a big data center there, which would in turn make me look like to the GSLB system that I am over in New Jersey and might get routed all the way across the country. Resolvers also might be shared by a whole pool of users all across the world, so the GSLB has to make a best guess and say, well, I guess on average you're close to London, but some users are real far away from that, some are close. And also IP mapping data might not be accurate. A lot of the geo-IP data packs and systems for that are really targeting towards end users and where they're physically located. DNS resolvers are often in server networks or a lower priority to figure out exactly where they actually are. So you really don't have a guarantee of accuracy. We've done a series of studies using web beacons for our end users and DNS resolvers, and have found that there's roughly about 90% accuracy in the US, or we can achieve that. And that's where inaccurate was over 40 milliseconds further away from the closest possible site. So in this situation, the options were, well, I could send somebody to San Francisco or to New York. I picked New York instead of San Francisco, and that ended up adding an extra 40 milliseconds worth of round trip time to me. One of the big questions that pops up with doing this kind of routing is, why would I do this at DNS? I just talked about some of the reasons why it would actually be inaccurate to do it. But there's alternative ways to do it. Of options would be, I could do a 302 redirect on HTTP pages. So you go to that page and it redirects you to the right close server and target directly based upon that user's IP address. Would end up with me having funky, weird URLs. Don't think anybody wants to bookmark westcoast.www.yahoo.com and would rather just be directed right to the main site. I could do magic with JavaScript or with iframes or other trickery like that to hide it away. All of that stuff would, be HTTP and HTML specific. And there are cases where you could use this for something else. Where I should route to the closest mail MTA or the closest IRC server or anything like that. The biggest overhead, and the reason that I like DNS for this, is that doing it with these other techniques would require at least one extra TCP connection. So you always have to send somebody somewhere first in order to decide where to redirect them to what's close. And if it's just your main landing page that you want to load really quickly, having to do one extra connection to first figure out where the closest place is going to add a chunk of overhead to them. Doing it with DNS, because it is cached, and usually GSLBs might do something between 1 minute and a 5-minute DNS TTL, which means that for all the users that are sharing that DNS resolver, there only has to be one new DNS lookup every 5 minutes. So the overhead of that is that a small percentage of users for a site that's getting a decent chunk of traffic, we're going to have to wait for an extra DNS lookup. But with a really good deployed DNS infrastructure, a lot of the big GSLB providers have huge footprints all around the world. It should only add a small extra amount of latency for that small percentage of users instead of having latency of sending them to a site, having it have to figure out where the closest possible place is, and then redirecting them there. Me being a BCP high availability guy, the thing that I care about more than anything is making sure that the site always stays up. So data center fails. No matter how much redundancy, we treat a data center as a single point of failure. My personal favorite, and the reason I threw a little lightning strike in there, is an old data center that we are not in anymore in Northern Virginia got struck by lightning, and it had a power outage. And we said, wow, that sucked, and it was terrible, but hey, that happens, whatever. And then 3 weeks later, it got struck by lightning again. It's not supposed to strike the same place twice. These things always happen, so the way we treat it as data centers will fail no matter how much redundancy you put in those routers and all that other stuff. So being able to move traffic to a different place that is far away and can handle both the earthquakes and the thunderstorms as well as the backhoes and the power grids failing is really huge. This is an example recently of something that happened where somebody fat finger to change to one of the routers, and suddenly all of our servers disappeared off of the internet. The big piece, GSLBs provide automatic failover, and how fast it is just based upon how short that DNS TTL is. With a 5-minute TTL, we'll see about 90% of traffic move in roughly 8 minutes. So from this graph here, the green line was the site that suddenly disappeared, or the blue line was the site that suddenly disappeared. You see it drops off, it's detected, and the traffic ramps back up as everything was redirected to the other site. And then the router came back up because the person rolled back their messed up change, traffic came back in, and then it shifted in and out again as things were kind of flapping a little bit. But the big piece with this is that 8 minutes for a traffic shift is faster than I can get out of bed when my pager goes off at 3 in the morning. I throw it at the wall and then have to figure out how to log into stuff. And it gives me the ability to have automatic failover, letting me be able to basically say, well, the data center got struck by lightning. That sucks. Call me when the data center is back up and running again, and I'll figure out how to get my stuff back in there. The other half of this, using a GSLB when you're deployed in multiple different sites and you can easily shift traffic, lets you do maintenance a lot more easily. If you're in a situation where you want to be deploying that new code out to production, you're really confident that that it worked because it worked in QA and it worked in staging, and you're ready for it to roll. But some stuff might be slightly different in your production environment. You can just shift all of your traffic away, push the code out there, see if it explodes. If it doesn't explode, then cool, we'll shift some users back into there. If it continues to not explode, deploy to your other sites. It gives you the ability to do easy, stress-free maintenances because you don't have to worry if things blow up because you can just shift traffic away. One of the big cool things that we've noticed is that not all traffic does move when you do DNS failovers. Sometimes it's the case where it's bad clients or weird DNS resolvers that are caching things too long, or OSs and browsers caching things for extended periods of time. But there's a lot of cases where you might just get really weird traffic that's going to your site. Somebody has a bunch of bots or a botnet that are just crawling your site for some reason, or you have Googlebot crawling you, or Yahoo's bots crawling you, or you're monitoring traffic. And it's really interesting to see what traffic sticks around on your site after you've moved all of the legitimate traffic away. We ran into a situation where with one of our pages, we did a traffic shift to do maintenance. Noticed that 20% of the traffic still hung out on that site. And we did a bunch of analysis, looked through all the logs and everything, and it turned out to be from a small number of IPs that were basically trying to crawl over the site all the time. We moved traffic back and said, okay, well, that was weird. We got a bunch of this extra stuff that's definitely not real people. And then a little while later, data center went down, and traffic shifted away, and it looked like we lost 20% of our traffic. But we knew that this was less than legitimate stuff anyway that we didn't really care about, so who cares if that didn't follow us? Limitations. So we have our GSLB system to handle shifting traffic all around across all of our geographically diverse sites. And it is, in a lot of cases, the big hammer that everybody wants to use and turn all of our problems into a nail. And it is not perfect at doing everything. One of the big challenges with it is shifting small percentages of traffic is difficult, if not impossible. GSLBs can definitely shift percentages of traffic and shift different chunks of it, but it's not anywhere near as accurate as doing it on like a per-user basis. Run into situations where you have a ton of users that are behind one DNS resolver on the left-hand side here. And then on the right-hand side is me with my computer and my DNS resolver that are both running in my apartment. From the GSLB's perspective, they're going to get one request every 5 minutes at most. So it can often be difficult to just move a small percentage of traffic. Also, for the big hammer situation, we have a lot of server-to-server traffic that moves between different data centers. Doing that in small granularity is nearly impossible. You end up with a cluster of servers that are using a few or one DNS resolver or a pair of them. So they'll do a lookup every 5 minutes, and all of those servers will get back the same answer, go whale on one cluster, and then will be directed because you're trying to shift that little bit of traffic and send it over to the other one. The other limitation, well, it's not as much of a limitation, but a consideration when you're deploying in multiple different sites and having some sort of automated system do balancing. is that there is no guarantee that your users will always go to the same cluster in the same session. Normally, you'd run into that within a single site and a single data center, but it gets a little bit trickier when you're doing stuff that's geographically dispersed. Browser and OS caches vary. So usually they'll cache stuff and won't do fresh lookups between clicking on different links, but sometimes they do. At one point in time, I tried to figure out all of the weird variations of it, but I've mostly given up and put it in the realm of they do weird stuff. So you have to assume that your users will hit multiple different sites and be prepared for that to happen. One of the biggest things that pops out of that is needing to plan for critical reads. So assume that when a user just wrote something into your new database that it hasn't replicated everywhere yet, and have some way to have a useful page come back up. You don't want to have your user write the newest epic blog post that they just spent 30 minutes putting together, click submit, have the page refresh, they get redirected to a different cluster of servers, and it looks like there's no content there, which will turn into the WTF piece of junk website, I will never come here again because you ate my content. When really, in truth, they just had to wait another 3 seconds for it to replicate halfway across the world. So in summary, what GSLBs give you, it's faster page load times. When you deploy in multiple different sites and let the GSLB get your users to the closest possible one of them, it gives you a faster page load and for free. CDNs use this technique all the time to distribute static content. There's reverse proxies that are set up that use this kind of thing. When you get users to a closer site, it's a free boost in page load performance. By far, epic uptimes. If you serve out of multiple sites, then doesn't matter when the power goes out. Doesn't matter if there is an earthquake, although I'm going to go with the knock on wood being in Northern California, because I don't want any of those. But you don't have to worry about that. It allows you to shift traffic all around to be able to handle things like any of your little maintenances, big maintenances, UPS tests, all sorts of those things. And it gives you simple traffic balancing. It's not going to be the right tool, right hammer for that 0.01% testing bucket of a new version of the page, but it'll be able to shift traffic around. And the biggest piece with that is that when you're using this and you have multiple sites, that you need to be prepared for the internet to always be changing and traffic should always be moving around. And that's what I got. I tried to keep myself short and sweet.
Yeah, that's good. That's great. There are actually a couple of questions, Dave, that was super helpful. One of the questions that somebody had was, do you have any statistics or a general idea of what percentage of DNS servers respect TTLs?
These days, I would probably put it within the 90%-ish realm. I don't have a number that I've done a significant study on. The reason I make that statement of 90+% is from those traffic shifting graphs that I showed, where we see cases where when we do a traffic shift within about 8 minutes for a 5-minute TTL, the majority of the traffic has shifted. So our experience is that these days, unlike before when things would just hold on to it for 30 minutes or an hour minimum, these days it seems like most DNS resolvers are actually obeying the TTLs.
I'll have a follow-on question onto that. Do you have any, or is this even anecdotal comments about any? Are there any geographic patterns as to what parts of the world may or may not, or is it honor TTLs, or is it a roughly equal schmear across the planet?
Generally, I've seen it be fairly equal. I have seen some anecdotal cases in Brazil where I think resolvers have been configured to cache things for longer just because they might have run into a lot of situations where DNS lookups would fail often, but that's only really been anecdotal cases.
Okay. Another question is, do you have any more stats on TTL versus actual end-user traffic shift?
The big stat of the 5-minute TTL for about 8 minutes for the 90% traffic shift is The best statistic I have for a 1-minute TTL, it's usually within 2 to 3 minutes. There is that 90%, after that 90%, there is that really long tail, and a chunk of that's just browser and OS caches. When there's an actual, the site is truly down, network doesn't work anymore, OSs and browsers are a lot better at doing fresh DNS lookups, but that long tail can be a long tail for 30-plus minutes.
Gotcha. Okay, I got another question, but I do want to point out that and I'm not sure if Jay Jansen works in your group anymore over there at Yahoo, but he's been pretty helpful in the group chat as people had questions throughout your slides here. So a bunch of questions that might have come through. I think that there's a bunch that have already been answered. One question that I had, and almost mostly a curiosity about the future. Do you expect to have these approaches for global load balancing to work the same with IPv6, and or does has Yahoo put effort and priority on working out these bounds? Not IPv6 deployment, but would these approaches be different?
It should be the same for IPv6. It'll still be the same basic layout of end users and DNS resolvers. The hope part of it is that for GSLB, for the DNS resolvers, the expectation is that those will stay as IPv4 for cross-compatibility for a while. But it should still be basically the same concept behind it. It's a bigger IP space, so hopefully there won't have to be too much more mapping to figure out, but it should be effectively the same concept.
Okay. Patrick Meenan's got a question. How accurate is the DNS geo-targeting, particularly with OpenDNS, Google, EC2?
That's a good question. That definitely throws kind of a monkey wrench into the targeting. So there is a experimental RFC that was put together, I think, by Google as well as Newstar and OpenDNS, I think, had a hand in it, to add the client subnets into DNS resolver queries. The idea for that is when you have those giant pools to send it off to GSLBs, they could at least get a better idea of where the users are from. I unfortunately do not have statistics about how well that's deployed at this point in time, but that was kind of one of the solutions for it. But it has been a problem in the past, because if everyone is sharing those resolvers, you can only have that level of granularity of, well, the majority of the users behind this IP that's querying us are within the southwestern side of the U.S., as opposed to having the accuracy of they are really close to this server in California.
Okay, so a little bit like hitting the side of a barn with a bullet. Really, there may or may not be some accuracy there.
Yep.
So and then there's one more here. How do you map a user to the closest server if their local DNS is further away from that? Is there a way around this? E.g., users in Arizona, LDNS is in Colorado. Will the server be Denver versus LAX?
Yeah, so in that situation, some of the techniques we've done is to stop just looking at the DNS resolver and try to identify where the majority of the users behind it are. So if that's the case where almost all of the users in Arizona are using that one resolver in Colorado, we could identify that it's a pool of users. And it's not that we're identifying they're in Arizona, but more just identifying that their network path is a lot shorter to Los Angeles than it is to Denver. And then we apply extra data on top to say, well, even though this request came from something that's really close to where we are in Denver, send it to LA instead, because I know all of the users are behind that.
Great. Cool. I think this is great. And having seen a decent amount of what your group does over there at Yahoo is always impressed. So we're at 2:23. It's about 7 minutes to go. there's I don't know if you have if you're in the group chat, Dave, but it'd be helpful, I think, if you stuck your head in there. Maybe some other folks might have some other questions in the last minutes we got here. I think this was awesome. I hope everybody had an informative time here. I think it's great that this is this sort of free forum, and I hope Riley does more of these types of online conferences, especially from companies like Yahoo and Broadcom and SEO Moz and the other company, I can't remember the name of it. Oh, Etsy. Because anecdotal, real-world, lessons learned types of presentations, those are the types of presentations that become conversations, and that's where all the learning comes from. So. Anyway, one last quick plug / reminder: the Velocity Berlin is happening November 8th and 9th, and there's some discount codes floating out there. I'm going to tweet a couple, and it's getting close. We're so Velocity in Berlin. First time Velocity's been in Europe. It's very close to selling out. And there's a lot of really good speakers there.